Okay, we have a series of statements. Okay, and I'm not sure. I actually wrote down what those statements were. Something like, if it rains, you'll get $100. If you get $100, you'll have a good dinner. If you have a good dinner, you're going to get indigestion. If you get indigestion, then you're not going to sleep well. So, your conclusion is what? If it rains, well, then this is going to happen, etc., etc. If it rains, then you're not going to sleep well. Okay? Now, symbolizing that argument, if P then Q, if Q then R, if R then S, if S then T, you conclude if P then T. You can draw this. Okay? If P then Q means that all P events are inside the circle of Q events. Okay? That way, anything that's a P is also a Q. That's what that means. And this says anything that's a Q is also an R, so you're going to have to surround the Q circle with an R circle. And then, if it's an R, then it's an S, so that the S circle has to encompass everything in the R circle. If it's an S, then it's a T, so the T circle has to surround the S circle. If that's the case, then very clearly the P circle is inside the T circle, and you conclude if P, then T. There are many other things you could conclude. You could conclude if S, then, if P, then S. If Q, well, if P, then R. If Q, then T. Lots of things, but the biggest conclusion you can make is if P, then T. Now this is called transitive reasoning. They're more formal names that we'll talk about, but we don't have to remember that one. Another statement. Okay? Statement is, it rains or you get $100. That's the way it's written in the document. So, if P stands for rain and Q stands for $100, this statement is not P. Actually, no, I'm sorry. I didn't say if rain then $100. The statement is, it doesn't rain or you get $100. Okay? That's coming back to this one with my first interpretation. Okay, so once again, the statement is, it doesn't rain or you get $100. Where P stands for rain, Q stands for $100, this stands for the statement. Okay? And then the other statement is, you don't get $100. Now, what does that tell you? Well, if it's going to be this or this, this says that it's not this. It's got to be one of the two. If it's not this one, it's got to be this one. So your conclusion is not P. Okay? It's either got to be not P or Q. Either not P or Q's got to be so, Q ain't so, so P got to be so. Conclusion, it didn't rain. Now, what if the statement was, if it rains, then you get $100, and it doesn't rain? Is there a conclusion you can draw there? Well, we say if it rains, you'll get $100. We didn't say what would happen if there's no rain. You can't draw a conclusion. You might get the $100, you might not. Okay, remember, you can't conclude a true from a false. You can conclude anything from a false, and rain turns out to, the rain condition turns out to be false. There's no conclusion that can be drawn. On the other hand, if the statement is if rain then $100, if you don't get the money, then if these statements are both true, the only way that can be is if it didn't rain, if the rain was false. So you want to be able to distinguish between these. Okay? And there are names for these: modus ponens, modus tollens, disjunctive syllogism. And we'll get to those names, but we want to kind of introduce the idea that we're talking about arguments and how to analyze arguments. And it clearly, These constitute simple arguments, or simple conclusions that can be drawn from a series of statements.